Hello students, welcome to CBSE Science Series. Today we are going to learn about relative permittivity or dielectric constant. We know a Coulomb force between two stationary point charges k q1 q2 by r square. Here k is the constant, that is 1 by 4 pi epsilon naught. Here epsilon naught is the permittivity of the free space, that is air or vacuum, and its value is 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. If we place that same charges in the same distance in any other medium other than air or vacuum, the force becomes 1 by 4 pi epsilon q1 q2 by r square. Here epsilon is the permittivity of the medium, or simply it is called permittivity. What do you mean by permittivity? When we place the charges in any other medium other than air or vacuum, the Coulomb force between the charges is reduced. That is called permittivity. Means permittivity is the property of the medium that decides the Coulomb force between the two charges. That is what permittivity. We know the force between the two charges in vacuum and the force between the two charges in medium. If we divide the two forces, we get 1 by 4 pi epsilon naught q1 q2 by r square, 1 by 4 pi epsilon q1 q2 by r square. Both q1 q2 r square get cancelled because we place the same charges at same distance in vacuum as well as in the medium. So both get cancelled. We get epsilon divided by epsilon naught. So this ratio is known as the relative permittivity or dielectric constant. How can we define relative permittivity or dielectric constant? It is the ratio of permittivity of the medium to the permittivity of the free space. Means epsilon r is equal to epsilon divided by epsilon naught. From this we can write epsilon is equal to epsilon naught epsilon r. It's a dimensionless quantity. It is simply a number. There is no unit for this. And we know the force in the medium is 1 by 4 pi epsilon q1 q2 by r square. So if we substitute instead of epsilon r epsilon naught, we get 1 by 4 pi epsilon naught q1 q2 by r square. We know that 1 by 4 pi epsilon naught q1 q2 by r square is the force between the charges in the vacuum. So the equation becomes force between the medium is equal to force between the vacuum divided by the epsilon r. This way the force is reduced when we place the charges in the medium, and epsilon r becomes the ratio of the force between the charges in the vacuum to the force between the charges in the medium. This epsilon r is also known as the relative permittivity or dielectric constant. So this is what another definition of the relative permittivity or dielectric constant, and its value is different for different medium. It is in vacuum 1, and air it is 1.00054, in water it is 80. So this is what about the dielectric constant or relative permittivity. Thank you.